Okay, so today we are going to be looking at vertical translation of functions. So our learning intention is, and this learning intention is going to be with us for a couple of lessons. It's the knowledge of the order in which transformations are applied and how they affect the original function or the parent function. So we'll be successful for this lesson if we can correctly identify and apply for the function of y equals f of x. If we have f of x plus c, well, this might translate the graph vertically up along the y-axis. If we have y equals fx minus c, it will translate the graph vertically downwards. So what we're looking today is really the translation up and down the y-axis of a function with a plus or minus c. So let us start. And we've been doing this a while with the Year 11 content and back in Year 10 with nonlinear relationships. So let's look at this example. We want to complete the following table of the values and then sketch the function on the same set of axes. Okay, so this is our first y equals x cubed, and that's going to be our, what we say, we're going to call that the y equals f of x. So our f of x, our parent function, is this x cubed in this situation. So if we plug into our calculators, so negative 3 cubed, we get negative 27. Negative 2 cubed is 8, so negative 8. Negative 1, 0, 1, 8, and 27. Okay, and that's just plugging in your values of x. Okay, so if I was to sketch that first, and I'll do that in blue. 1 is 1, 2 is 8, and 3 is 27. Not too big, so negative 1, 1, negative 2, negative 8. Something that looks a lot like that. Okay, now what we're going to do is we're going to have this y equals fx plus c. So this is going to be our y of f of x plus c. And the c at this situation will be 2. So what happens to our function? So using our values, we get x is negative 3, we cube it, and then we add 2 to it. Okay, and that will give us negative 25. We have negative 2 cubed, then we add 2 to that solution, so we get negative 6. So looking at these values, all we're doing is we're adding 2. So negative 1 plus 2 becomes 1. 0 plus 2 becomes 2. 1 plus 2 becomes 3. 8 plus 2 becomes 10. And 27 plus 2 becomes 29. Just double check. So I've got, 2 cubed is 8%. Okay. Yeah. Okay. So now what I'm going to do is I'm going to actually sketch this, and I'm going to sketch it using a black marker. So we've got 0, we have 2. When it's 1, we get 3. 2, we get 10. Okay, a bit too much. Negative 1, we get 1. Negative 2, we get negative 6. Okay, so what I really want you to notice is the gap in between these points is 2 units. Yeah. And what occurs is we get the same function, however, it's translated up the y-axis by 2 units. Okay. So let us do some other examples with that information. So to reiterate, when we have a function y equals f of x, if we add c, it translates it up the y-axis. If we have negative c, it translates it down the y-axis. So describe how the constant in y equals x squared plus 3 affects the graph of y equals x squared. So this is our parent graph. And now we've got y equals f of x. If we add 3, all we are doing was translating y equals x squared up the y-axis 3 units. Okay, and if I was to use Desmos to show you, we get y equals x squared. There's your parabola. And if I have plus c, and c is going to be my variable, it made it c equals 1. If I have c equals 3, you can see that it moves it up 3 units. If I give you the original parent graph here, you notice that it has translated the whole parabola up 3 units. Okay. If we want to find the equation if y equals x squared is translated 3 units downwards. Well, if that's the situation, it will be y equals x squared, the parent graph, and we're going downwards, so we're subtracting 3 units from our x value. Sorry, from our y value. Okay. Next example, find the equation of the transformed function if y equals 2x cubed plus 3 is translated 6 units up. Well, remember what we're doing is we're translating the parent graph up the y-axis by 6 units. So here is our parent graph. We technically start here, which is a cubic with a rate of change of 2, and it's up 3 units. We're translating an additional 6 units. So the translation now would be 2x cubed plus 9. Here we want to translate it down. So there's your parent graph. We're going to translate it down the y-axis. So we're going to subtract it by 4. So our new function becomes 3 minus 4 is minus 1. Okay. If a point, 1, negative 2, lies on a function, find the transformed image, find where this point will move to if the function is translated 6 units up. So in this point, if we're translating it vertically up the y-axis, we are changing, there is obviously a change in the y value. Okay. So you've got to remember it's going to be a change in the y value. So if we have the original point of 1, negative 2, and we're translating the y value, we're going to add 6 units to this. So the new point will be 1, negative 2 plus 6 becomes 4. So 1 dash 4. Here we have 1, negative 2, and we're going to translate it down. So we're going to subtract 4 units to it. So the new point will be minus 2 minus 4, minus 6. Okay, and that's it. So remember that if you have a function y equals f of x, and then you add a constant or subtract a constant from it, that would translate the graph up or down the y-axis depending on your constant. Okay, thank you very much.